Hello, Year 8. So have a think of any chemical formulae you know. For example, water is H2O. Write them down. We'll have a look at them a bit later. Okay, so today's lesson is on ratios. Now, our chemical formula for water was H2O. Let's have a think about what that means. It means that for every one oxygen atom, there are 2 hydrogen atoms. So the 2 goes with the H there. If I wanted to write this as a ratio of hydrogen to oxygen, I would write 2 to 1. 2 atoms of hydrogen to 1 atom of oxygen. That order is really important. The ratio of oxygen to hydrogen would be 1 to 2. So, we use ratios to compare quantities. We write them as a number, then a colon, and then another number. We read this as 5 to 7 in this example here. As I said before, the order of a ratio is really important. 1 to 2 is a different thing from 2 to 1. So let's imagine we wanted to know the ratio of Hawks to Demons fans in the class. Now, I'm not going to ask you, but let's say that we had got 6 Hawks fans and 7 Ds. So the ratio of Hawks fans to Demons fans would be 6 to 7. If we wanted to write the ratio of Demons fans to Hawks fans, we would write 7 to 6. Now, we can simplify a ratio by dividing both parts by the highest common factor. So here I've got the ratio 8 to 12. Now 2 is a common factor of 8 and 12, but 4 is the highest common factor. So I want to divide both sides by 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. Now let's check. Do 2 and 3 have any common factors apart from 1? No, they don't. So my ratio is in its simplest form. Now let's have a look at these 3 examples. So we're going to simplify first 55 to 65. Now I can see that 5 is a common factor of both of these, so let's divide by that. 55 divided by 5 is 11. 65 divided by 5 is 13. 11 and 13 don't share any common factors apart from 1, so this ratio is in its simplest form. Here, the 2 parts of the ratio are in different units of measurement. I can't simplify it while they're like that, so I need to start by rewriting this side, 3 meters, as centimeters. Once I have the same units of measurement, I don't need to write any units of measurement. So now I have 300 to 120. Now I know that 30 is a factor of both of these, so let's divide both parts by 30. So I get 10 to 4. Now 10 and 4 also have a common factor of 2, so I need to simplify again to get 5 to 2. You can simplify multiple times. It's best to write them underneath each other rather than going across like this, but this can be acceptable. It just gets a bit more messy. In example C, I've got decimals in my ratio. I don't like having decimals there. They've got to be whole numbers. So either I could multiply both of these by 10, that would give me 25 to 45, or I could multiply them both by 2. I'm going to multiply them both by 2 because that's smaller and so it's going to make things easier for me. So 2.5 times 2 gives me 5. 4.5 times 2 gives me 9. 5 and 9 don't share any common factors, so I'm finished. Let's just have a look at what I would have done had I multiplied them both by 10. 25 to 45. Now both of these have a common factor of 5, so I can simplify. You see I get the same answer both times. Can you pause the video now while you have a go at these questions here? 12, 13, 22, 23 are extension questions. Have a go at them if you would like to challenge yourself or if you found these questions very straightforward. Make sure you mark your work before moving on. Okay, so an alloy is a metal that's made up from other metals. In this example, we have an alloy made from zinc and copper in the ratio 3 to 8. I want to know the fraction of zinc in the whole alloy. So there are 11 parts in the whole alloy, 3 parts zinc, 8 parts copper. Add them together to get 11 parts in the whole thing. 3 parts are zinc. So the fraction of zinc in the alloy is 3/11. Pause the video while you have a go at question 4. I'll go through question 4 quickly with you here. So, total number of parts, we've got 63 parts altogether. The fraction of native trees in the park is 23 out of 63. The fraction of exotic trees, 40 over 63. Okay, let's look at another example. So we're going to look at this one first. 1/10 of the population is left-handed. What's the ratio of left-handed people to the rest of the population? So the rest of the population, the total population is 1. Subtract the 1/10 of left-handed people. That gives me 9/10. The ratio of left-handed people to right-handed people, so we've got 1/10 of the population to 9/10 of the population. I don't like having fractions in my ratio, so to get rid of the fractions I can multiply both parts by 10, and so that gives me a ratio of 1 to 9. Pause the video while you have a go at the second example. Okay, so 1/3 of the flowers in a garden are blue. What is the ratio of blue flowers to other coloured flowers? So other coloured flowers, 1 subtract 1/3, that gives us 2/3. So the ratio of blue flowers to other coloured flowers is 1/3 to 2/3. I don't like having fractions in my ratio, so I multiply both parts by 3 and I get 1 to 2. Okay, so now you can complete questions 7, 8 and 10. Make sure you mark your work and ask your teacher if you have any questions. Thank you.